All right, I think we can go ahead and get started then. Um, Hopefully, and yes, Richard, absolutely. Please send in a recording. We will make it available. I assume that we'll just post a link in the workshops channel on our public Slack, but we'll get it sorted out. Um, there you go. Catherine's just posted a link to the Linkerd Slack. We're in the workshops channel there. If you have questions as you're following along, that's the place that will be most useful to do it. And in the meantime, let's go ahead and get started. I'm Flynn. I'm a technology evangelist here at Buoyant, but that's not all that important right now. The important bit is Eliza, who is one of the Linkerd maintainers at Buoyant. Eliza spends a bunch of time hacking on Rust and working on the proxy and all sorts of cool things like that. And yeah, Eliza, over to you. Take it away.
Thanks, Flynn. Yeah, so today we are going to be talking about multi-cluster failover with Linkerd using the Linkerd failover and Linkerd multi-cluster extensions. So next slide, there we go. Okay, so this is me. Some of you may have seen me on GitHub or on Linkerd Slack or on Twitter where I post pictures of my cats and stupid computer jokes. As Flynn said, I'm a Linkerd maintainer. I work mostly on the proxy. And so here's what we're going to be talking about today. One, what is Linkerd? Most of you are probably already at least loosely familiar with Linkerd. Hopefully some of you are using Linkerd. And then we're going to be talking about why Linkerd is in a good position to enable support for failovers. What is the Linkerd failover extension and how it works? And then we're going to walk through the workshop itself. So what is Linkerd? Again, hopefully this is, I gave this talk at a different conference. Hopefully more of you are at least passingly familiar with Linkerd. So as many of you probably already know, Linkerd is a service mesh. It provides Kubernetes applications with features related to observability, security, and reliability. And the failover extension falls into the category of reliability features because it ensures that requests are handled and that uptime of the application is maintained, as it says right there. So here's the Linkerd architecture. This is sort of a 500-foot zoomed out view. So we have this big sort of blue squircle here, this rounded rectangle. It's got sort of a hand-drawn Kubernetes logo on it. So this is the Kubernetes cluster, right? And inside that cluster, we have some pods, and those are these squircles over here, the purple ones. We have some application container A, some application container B, and some application container C. And then inside of those pods, we also have a container that is a Linkerd proxy container. So that's this little Linkerd logo. And the Linkerd proxies talk to the injected application container or containers in those pods. So a little arrow between the Linkerd logo and A, B, and C. And then the Linkerd proxies receive connections that those application containers might be opening to talk to the outside world. And they go through the Linkerd proxy, and then the proxies forward traffic between each other and then to the other containers in those pods that are injected with Linkerd. Then over here, we have the Linkerd control plane, and that is sort of a set of Kubernetes controllers that run in the Linkerd namespace. And they talk to the proxies, and they tell the proxies things like, how do you route traffic inside the cluster? They send the proxies routing policies. The proxies do service discovery against the control plane, and the control plane collects metrics and other data from the proxies. It's also responsible for ensuring that when you annotate a namespace or a deployment or something with the Linkerd inject annotations, that proxies are actually added to any new pods that are created in that namespace or in that deployment, and ensuring that those proxies are configured correctly. So that's sort of the bird's eye view of what is Linkerd. So now let's take a minute to talk about failover. What is failover? Why are we using Linkerd to do failovers? So failover is a reliability technique. It's part of this sort of broader category of circuit breaking, right? Which is the idea that if you are, you're talking to some external service, like you have some service and you're talking to some other service, and that service stops being your friend. It starts returning a bunch of errors or you don't hear back from it, your requests don't come back, you want to maybe stop talking to it because it's in a bad state and you want to try to route around that. So failover is something people have been doing failover for about as long, of one kind or another, for about as long as there has been a formalized practice of engineering, not just in computers, but in the power grid, they will fail over from one power plant to another power plant. And basically what you're doing is you have some primary service that is providing some service to your system. And if it goes down for some reason, you have secondary or backup services. Sometimes they're called standbys that you start using to provide that same service, but it's a different instance of that service. So this ensures reliability because if there's some error, some failure, you can just get the service that you need from something else in the system. So in this, oh, go ahead, Flynn.
In your head, are failover and load balancing related or competitive or whatever?
So
how do you see their relationship there?
That is a great question. In Linkerd in particular, there are sort of multiple layers of load balancing and multiple layers of failover. In this example, we are going to be talking about failing over. This is actually sort of where these slides are about to go. We're going to talk specifically about failing over between Kubernetes services, right? So in this is actually what this slide is about. So in this drawing, we have some Kubernetes services, A, B, and C. A is the primary service. And what we're going to be doing is we're specifically going to be watching, are there endpoints in the A service? And if there are endpoints in the A service, then Linkerd is going to load balance over those endpoints, right? Because a Kubernetes service has potentially any number of pods in it. And those pods each individually provide one endpoint that serves that service. And Linkerd is load balancing at the level of endpoints because a service is a resource that represents one or more pods that provide a given service. And I realize I keep saying service both with the big S, right? The Kubernetes S service, and little s, like the concept of a service in the abstract. But those services are more or less like each pod in a service is the same thing. It might be the same version of that service, the same containers of that application, right? So we can sort of rely on those endpoints if they're stateless to give us the same thing no matter which endpoint we talk to. And because we can rely on them to behave identically, we can load balance over them. Now, Linkerd does do a form of service break or of circuit breaking within its load balancer. So that's not what we're going to be talking about today. But we have some behavior where if an individual endpoint within a service goes down, we just load balance over the remaining endpoints. So Richard has a question about stateful services. Some services are stateful. We are talking primarily in this demo about the Kubernetes service resource and not stateful sets or anything like that. I imagine you can use the Linkerd failover extension to fail over between stateful services as well, but there's additional work that you'll have to do to make sure that the state is replicated, right? And we're not really going to go into detail on that today.
So Linkerd is going to be worrying mostly about failing over requests and such, and managing the replication of state for stateful things is kind of a whole different thing.
That is a whole additional can of worms that there are other tools that you would probably want to use to do that.
Which you could use with Linkerd to handle failing over
requests. Absolutely, you would want to even. Like if you know that, and again, in this specific workshop, we're going to be covering failing over between different Kubernetes clusters with Linkerd's multi-cluster features. So if you have some stateful service that is in your primary cluster or in a specific, like in US East 1, and you have the same stateful service in US West, and you have ensured that, so the stateful aspect of failover, Ahmed is asking, is not, this isn't something that Linkerd, so I
Let's
mean, we
maybe an
can't.
easy way to deal with that one is simply that that sounds like a potential great topic for a future workshop. If we
Yeah,
could talk about something like that. This one, I think we do want to focus a little bit on request failover.
right.
So, and actually, Eliza, I think your next slide is getting into some great stuff
Yeah,
about where Linkerd comes into this.
right. So okay, so let's go to the next slide. The reason that we're using Linkerd is because Linkerd is positioned in a layer of the stack where it can make routing decisions about network traffic in the application, right? So all of the traffic in an injected application is flowing between Linkerd proxies. And so the Linkerd proxies can do traffic shaping and decide where those requests are going. This is why, just going back to the question about statefulness, the state that may be replicated or may not be replicated is not really the kind of problem that Linkerd solves. If you have a situation where you have set up your stateful services so that the state would be replicated from one cluster to another, Linkerd can then fail over the actual requests from the primary to the secondary cluster. It will not do the state replication because it's not a database, but it will handle the actual routing of traffic from one cluster to another or from one service to another. So we're using Linkerd because we don't really have to implement any of this. And this is sort of the magic of the service mesh, right? Is that this routing of traffic is a network layer concern. If you have Linkerd installed, then you sort of just rely on the network itself to provide intelligent traffic shaping. You don't have to implement all of this failover logic in the actual application. It doesn't have to say, if I'm talking to a service and it goes down, then I want to talk to a different service. Linkerd can handle that policy outside of the actual business logic in those application containers, and it can do that in a way that's consistent. So if you have a bunch of microservices, you don't have differences in behavior in routing logic between those microservices because they're not implementing the traffic routing. Linkerd is doing that. And you just set policy, and you can do that in the Linkerd control plane. And that's the other bullet point here, is that in the Linkerd failover extension, we configure failovers using the TrafficSplit resource, which is a CRD that's provided by the service mesh interface spec. So this is sort of a standard interface for traffic splitting and traffic shaping. And we are implementing failover on top of that, sort of using the Kubernetes primitives. So this dovetails into what is the Linkerd failover extension that's actually providing this failover capability. And it's fairly simple. What it is it's a Kubernetes controller, right? Like the ones in the Linkerd control plane, but this one runs in the Linkerd failover namespace. This is sort of an extension that you can add to an existing Linkerd installation. It's optional, and it's actually not, it's not bundled with the Linkerd CLI yet because it's a new extension that's still being tested out, although people are using it in production. And what it's doing is it's adding this Linkerd failover controller. And what this controller is doing is, this is actually also one of the first Linkerd control plane components that we wrote in Rust. Typically, we've written them in Go. We wrote this one in Rust, which was sort of a fun experiment, and it proved to be pretty successful. And so there's definitely going to be lots of new Rust components in the control plane in the future as well. But that's not really important. It's just sort of a fun fact. And this controller is watching TrafficSplit resources. And in particular, it's looking for traffic splits that have this annotation failover.linkerd.io/controlled by Linkerd failover. And that label is telling this controller that traffic split represents a failover configuration that it cares about. And then that controller, what it's actually going to do is it's going to then watch all of the services that are in that traffic split, and it's going to say, how many endpoints are available in that service. And if there aren't endpoints available in that service, it will then edit the traffic split resource, right? Which again is just a Kubernetes CRD. It's going to change the weighting for that traffic split to route traffic to a different place. And then the Linkerd control plane, the core Linkerd control plane is consuming the traffic splits. It's watching traffic splits, and it's actually telling the proxies where to route traffic based on those traffic splits. And this is kind of an interesting architecture. I think that might be on the next slide. Oh, it's not. This is kind of an interesting architecture because this failover controller is never actually talking directly to the proxies. It's just watching and editing Kubernetes resources that exist in the cluster. And then the Linkerd control plane is watching the same resources again, the traffic split, and is actually telling the proxies what to do based on that. So this is kind of a neat example of how, and maybe this is a little bit in the weeds, but I think that it's kind of nice, that with Linkerd and with especially the Linkerd control plane, we've tried very hard to make things simple and modular, and specifically to use Kubernetes primitives that already exist in the ecosystem and to design the control plane in sort of a Kubernetes-centric way. This controller itself doesn't talk to the proxies. It just edits traffic splits. And traffic splits are from SMI, the service mesh interface. So there might be a number of traffic splits that you might be using for a number of things, and that they might even be able to configure things other than Linkerd. So here's an example of the YAML for a traffic split. I hope the font size on this is big enough that you can read it. If it's any bigger, it will wrap the text and it looks really bad. But so what we see here is that this is a SMI spec traffic split resource, right? And then in the metadata, we say, the name of this traffic split is sample service. And then it has an annotation that says, and this is a failover Linkerd IO annotation. Oh, I didn't mean to do that. That's called primary service. And it says that A is the primary service. And then we have this label controlled by that is telling the failover controller, this is a failover resource. You care about this one, you're going to be editing it. And then we have in the spec for this, we have a service. So this is the Apex service is A. And then we have a set of backends that's a list of services and weights. This is how a traffic split works, is that it's a list of services and weights. And a weight is telling the traffic split, like what percentage. They're not percentages, they're like, they're fractional numbers, but it's telling you how much of the traffic is going to that backend. So in this case, service A has a weight of 1, and all of the other services have a weight of 0. And that means that 100% of the traffic is going to service A. And you can use these traffic splits also to do like sending some fraction of the traffic from one backend or to one backend or to a different backend. We're not going to be doing that for failover, because in failover, if we have this primary replica and it goes down, we want to send all of the traffic to a failover replica, one of the standby services. We don't want to do like, oh, only failover 3% of the requests. You might want to use that for things like blue-green deploys, which we can also do with Linkerd using traffic split, but that's a different workshop. Or you might want to do, I don't know, you might want to do some percentage goes to, there are any number of things that you might want to do with the traffic split. We're only going to be talking about weights of 1 and 0 for failover, because something is either failed over or it's not. And so this is, if you have this YAML on your cluster, then the Linkerd control plane's destination service, which is the service discovery component, is going to be reading this failover or this traffic split and telling the proxies, hey, if you want to talk to service A, you're going to send all of your traffic to this backend. And the way that we would then fail over if service A here goes down is we would change the weight from 1 to 0 for service A, and we would change the weight for a different backend from 0 to 1. And that would be saying, okay, now all of that traffic is, oh, I didn't mean to scroll there. Oh God. We would be saying now all of that traffic is going to that other backend. So it's time to actually go through this workshop. There's a
Actually,
link. Oh,
before
go
we
ahead.
jump
Flynn.
on to trying it, there was a question a couple of minutes ago asking
What was that?
about how the failover stuff would interact with a Kubernetes API gateway. And I think that the answer there is that the API gateway would just look like the client and Linkerd would do
Yes.
its failover thing, right?
Yeah, that is the answer. Is that if you have some API gateway. Now, I will add, like an API gateway itself, it might have its own failover logic, right? A lot of them implement some kind of failover, some kind of circuit breaking. But if your API gateway is injected with Linkerd and it's just acting as a client for the rest of the mesh, it would just behave exactly the same as any other service that you might mesh with Linkerd, right?
Yeah.
Any other client service. So if there's a TrafficSplit designed for something that the API gateway wants to talk to, and Linkerd failover fails over between one backend to another for that TrafficSplit, then it just works.
Yeah.
It's totally modular. It's not something, I mean, obviously, like depending on the API gateway's other behaviors, there might be issues integrating it with Linkerd, there might not be, but the failover thing, it should just work.
And
are there any other questions we want to talk about now before we actually get into the workshop? I see there's a question from Matt about metrics. We're going to look a little bit at that.
Yeah.
There are a bunch of metrics that if you have Linkerd Viz installed, that will be in the Linkerd Viz Prometheus instance that you can use to get information about failover. I'm going to show you how to do that from the Linkerd command line and with the Linkerd dashboard in the workshop. But you can also consume those metrics as part of a custom alerting pipeline or add them to your Grafana dashboards or whatever you want to do.
And there's also a question about GCP load balancers and Linkerd. I think that one, gut feel on that one is it's probably better to take to the Slack channel. But
let me scroll here and try to find the question.
But also maybe something that comes up, so sorry, that may be something that gets covered during the workshop.
Oh, yeah, I see. That seems like a question for the Slack channel. It's not really related to what we're going to cover today. So let's actually start the workshop.
Get into it.
So what we have here is I'm going to give everyone a few minutes to actually check out the workshop repository. This is github.com/buoyantio, capital B, capital I, capital O. And then the repository is called Service Mesh Academy. If you've come to a previous Service Mesh Academy workshop and you already have that repository checked out on your machine, you're just going to need to pull the latest version of the main branch. The workshop materials for this workshop were added yesterday, so make sure that's up to date. If you have not checked out this repo, I'm gonna want you to do that now. And inside this repo, there's a directory called multi-cluster failover. Everything we're going to be doing is in that directory. It has a README file. Let me actually just get that up on my screen for a minute. I'm going to stop sharing this. And just so that everyone sees what this looks like, I am going to quickly share this window. So this is what you're going to want to be looking at. You're going to want to check this out. There are some configs here, and then there's this README. And the README lists everything you're going to need to actually go through this workshop. You should have gotten an email that mentioned some of the requirements. So hopefully all of you have everything set up ahead of time. But if not, we have this README file here. And the README has all of the steps we're going to do to set up the failover configuration. So if you're following along and you have some issues, you get lost, you can always pick back up from this README. Flynn, how long do you think we want to wait for folks to get ready to actually walk through the workshop?
Let's give them like another minute, literally.
Okay, in that case, I'm going to go get a cup of coffee. I'll be right back.
That sounds like an excellent thing to do. And to restate, if you are trying to follow the directions and are running into problems getting the repo checked out or whatever, Slack channel's the best place to bring that up and see about getting some help. But in the meantime, if anybody has other questions that we might be able to quickly answer, then we've got another 30 seconds or so. Probably also worth pointing out that, as was mentioned in the getting ready email that I hope you all got, since this is multi-cluster, we will be using 2 clusters.
Yeah.
And yes, the README talks about a cluster named East and a cluster named West.
Right. All of and that's what I've named mine. I can actually show off my, I'm going to share a different window now. I actually share my terminal here. So what I've got here is I have 2 clusters. Mine are running in K3D. I've actually, I'm SSH'd into my Linux box because Zoom screen sharing doesn't work on Linux very well. So I'm on my MacBook, but I have SSH'd into my Linux box, which is why if you ever notice like there's some lag when I'm typing, it's because every keystroke that I'm sending is like going across the internet into like a tail scale data center and then like back into my desktop that's like 3 feet away from me. Because of screen sharing reasons.
We're going to have to talk about that a little later, I think.
Yeah, okay. Well, so setting aside the like cursed details of my like personal dev setup, what we have here is I'm running these clusters in K3D. They're both running on the same machine. They're single node clusters running in Docker, but you could be running them on K3D. I think you can run multiple clusters at the same time with Kind. I have never tried to do it in Minikube. It might be possible. It might be a pain. Or you may have just spun up some small clusters with your favorite cloud provider. In the past, I've done this demo with Civo. Civo is really nice and easy to set up. Sort of, this is not a paid endorsement. It's just kind of a good experience to set up small dev clusters. You could spin them up in GCP, whatever works for you. But you need 2 clusters. And if you are copying and pasting things from the README, those clusters are going to be named East and West. They don't have to be named East and West, but obviously, but if you are copying the like bash snippets out of the README and pasting them into your terminal and your clusters aren't named East and West, you're going to have a bad time. So if you are using K3D and you run like K3D cluster create and you give it the name East, it will actually give you a cluster in your kubeconfig that's named K3D-East. So you can use kubectl config rename context to rename those contexts to just be West and East. That's mentioned in the README as well. So the first step that we have here in the README, we're just going to check that we actually can access those clusters. So we're going to run kubectl get pods in the kube system namespace. And we're going to try that for the East cluster. Okay, so we can see that it has a kube system namespace and it has some pods in it. So this cluster is alive and it works. And then we're going to do the same thing for the West cluster. And that one is also alive and it works. And then the next thing we're going to do, actually, I'm going to go ahead and set the West cluster as my default because I'm going to be running like some additional commands. Everything in the README, again, if you are copying and pasting out of the README, every kubectl command, every Linkerd command explicitly passes a context for the cluster that it should run against as an argument. So it doesn't actually matter what your current default kube context is. I'm going to be running some additional commands to actually display stuff, and I don't want to type like -- context West every time. So once we have verified that these clusters are live and that we can talk to them, we're going to check that we can deploy Linkerd on those clusters. So hopefully you have the Linkerd CLI installed, and the version that we're using is the latest one. So I believe that is now 2.11.4 is the latest stable Linkerd. So we're going to run Linkerd check -pre. So we're going to do the pre-flight checks for Linkerd that are going to verify that we can deploy Linkerd to our kube cluster. We're going to do that for East, and it's going to do some checks, and it says that the status check's okay, and that this is a bad look for me as a Linkerd maintainer. My Linkerd version is one minor release, one patch out of date. Oops, I should have updated it right before the demo so that it didn't print that, because that's a bad look for me. And we're gonna now do the same check for the West cluster.
Just for the record, for purposes
matter.
of this workshop, 2.11.3 and 2.11.4
Yeah.
are equivalent.
We just want to be on stable 2.11 because this workshop, all of the configs and stuff are written against stable 2.11. There's just a few bug fixes in the patch that don't really affect anything we're going to be doing. So we have now verified that Linkerd can be deployed on both of these clusters. And then the next thing that we're going to be doing, this is something that you wouldn't have to do if you were just installing Linkerd onto a single Kubernetes cluster. But this is something that we're going to be doing because we want to set up multi-cluster. And in order to enable multi-cluster communication with Linkerd, we want to have shared trust routes for Linkerd's MTLS, right? We want to be able to do encrypted MTLS communication between our two clusters. And in order to do that, we need some shared root of trust. And in that case, that's a root key that we're going to be generating using small step. So this is why in the instructions, it says that you should install the small step CLI. We're going to use small step to generate a root CA certificate, and then we're going to create issuer certificates for the East and West cluster that are part of the chain of trust for that, the train of trust. I like that, that's cute. They're going to be part of the chain of trust from that root certificate. And then when we deploy Linkerd on our clusters, we're going to configure the Linkerd identity service to have that trust anchor and to sign certificates for Linkerd proxies with the issuer certificates that we're going to generate. Now, because this is just a workshop, we're just doing this for educational purposes, we're going to generate these certs with no password. They're going to be pretty insecure. In real life, of course, you would want to keep these root certificates for your multi-cluster CA. That's very important. You probably want an offline root CA or some kind of HSM, or you follow like real security practices to keep these certificates very secure. In this workshop, we're not going to be like running anyone's PII around in this multi-cluster setup. This is just for educational purposes. So we're going to pass a bunch of scary looking flags to small step that are going to say things like insecure and no password. Which is fine for our purposes. Obviously, in production, in real life, you wouldn't do that. So first, we're going to run step. Oh, and as you can see, I have run this previously. Step certificate create. So we're saying we want to create a certificate. It's going to be named root Linkerd cluster local. And we're going to say that the file we want to save this in is root.crt. And root.key, so that's the certificate and the key file. And the profile for small step is that this is a root CA certificate. And then we have these scary no password and insecure flags, which are just saying, this is just for testing. We don't care. This is a demo certificate. So we're going to generate that cert. And then small step says, okay, your certificate has been saved in root.cert and your private key has been saved in root.key. Great. Okay, so once we've created that certificate, we're going to create leaf certificates in that trust chain. We're going to create one for each cluster. Again, if you're following along from the README, this is step 3. So step step certificate create. And this is going to have the common name wow, I can't type, identity.linkerd.cluster.local, and we're going to make the east issuer .cert. And again, I have run this previously, so I'm not going to type out the whole thing, except that it looks like there's a rogue white space character that's going to break this command. So I have to fix that. Let's try that. Okay, so we've generated the issuer cert for the East cluster. And then we're going to do the same thing for the West cluster. So that's step 3. We've generated the key pairs for the root CA and then issuer certs for both clusters. Once we've done that, we can now actually deploy Linkerd onto our clusters. We had to do all of this stuff with small step first because we wanted to have a shared trust root for the Linkerd identity service on both of these clusters. So we're going to run Linkerd install. We're going to do it for the East cluster first, and then we're going to write --identity trust file root.crt. So that's saying this is the trust root for this Linkerd installation. This is like the trust root for the chain of trust for the certificates that are going to be signed by the Linkerd identity service for each proxy. And then we're going to say identity issuer certificate file is east issuer.crt and identity issuer key file is east issuer.key. So we're going to say you're going to use the issuer cert and the issuer key that we just generated as a leaf certificate of that trust root. And then we're going to pipe this command into apply --context east. And we're going, so this Linkerd command is going to output a bunch of Kubernetes objects as YAML. This is sort of a nice, actually what we can do if we want to look at that is we can, instead of piping that right into kubectl apply, let's pipe that into a file. This is sort of a nice thing with the Linkerd install workflow, right? Is that we can just output, this is just going to output some YAML. It's not ever going to directly talk to Kubernetes. So we can actually look at that before we deploy it on our cluster if we want to. So we have.
Everyone should read the YAML carefully. There will be a test later.
There will definitely be a test. There's lots of hidden fun stuff in that YAML. It's going, there's some jokes in there that if you look carefully, no, this is a lie. So, it outputs a whole bunch of YAML, as we can see, and it's configured based on the various flags that we passed in. We're not going to actually read over all of this because it's like a huge pile of config, but it does have comments in it. It'll output some comments that tell you what's going on here. And so we can look at that. This is just a bunch of Kubernetes objects that are being created. So now we can run kubectl context.
It is worth noting, while Eliza is typing this, it is worth noting that YAML file, you may have seen a key in it. And probably not a great idea in the real world to take those YAML files and email them around or whatever.
Yeah, these are, you're going to want to be careful with them because they have that key material. Anyway, so we have deployed Linkerd on the East cluster. We're going to do the same for the West cluster. And this time I am not going to, do the whole intermediate step where I'm going to pipe that into a file because it's just to show that we're going to get this YAML back. So I'm just going to run the whole command and pipe it straight into kubectl apply. Okay, so now that we've installed Linkerd, we can run, this isn't in the steps. What we just did was step 4. Just to verify that we have installed Linkerd correctly, we can run Linkerd check --context west. And it is checking that Linkerd is installed on the West cluster. As you can see, this is sort of spinning here for a minute because that cluster is still like scheduling the pods that we just created. So we can do something similar in this terminal. This is why I have two terminals, --context east. So here we're going to see similar checks. The east cluster is like all ready to go because I ran the install command first and then I was talking for a while. We're going to wait a minute here for the west cluster, and now the west cluster is ready. So that Linkerd check command will tell you if there's anything wrong with the installation. It will also allow you to wait for the installation to be ready if you just installed Linkerd. So if some of the things that Linkerd needs, some of the pods in the Linkerd control plane, some of the resources that Linkerd cares about haven't been created yet, it will keep spinning there until they exist. So that if you then, you can even use it like Linkerd check and then run some other command if you want to ensure that that command isn't run until Linkerd is fully installed and ready to go. So Linkerd is now fully installed and ready to go. The next thing we're going to be doing is installing the Linkerd Viz extension. Linkerd Viz is an extension for Linkerd. So again, this is like Linkerd itself. The core Linkerd installation just gives you the proxies and the control plane components that the proxies need to run. Linkerd Viz is going to install a bunch of extra nice stuff for collecting metrics and for getting diagnostic data about the Linkerd installation. It's going to install a Prometheus instance. It's going to install Grafana and some pre-configured dashboards. It's also going to install the Linkerd web dashboard and services that are used for the Linkerd CLI's debugging and diagnostic tools. So in the README, there's a little script you can paste. I'm just going to do it manually. I'm going to run Linkerd --context east viz install. And Linkerd Viz is an extension, so you don't need it. You don't have to install it, but it is sort of bundled with Linkerd, so you can install it from the Linkerd CLI directly.
It's also really nice for figuring out what's going on later.
Yeah,
too.
it is the kind of extension that for most people, you're going to want to install Linkerd Viz as like the first thing you do after you set up Linkerd, but it's a modular extension. If you don't need this stuff or you have some custom setup, you can skip it, right? So this is sort of, I would always install Linkerd Viz, but it is something that you can live without. It's not necessary for Linkerd. So we can run same command for the West cluster. And now that Linkerd Viz is installed, I can run commands like Linkerd Viz dashboard, which is, okay, we're waiting for Linkerd Viz to come up. This is going to open the Linkerd web dashboard. In a minute. We're probably pulling some Docker images on my desktop PC. Okay, so this is now going to port forward, and I'm going to share my browser window for a sec here. Chrome window. I'm going to share that. So everyone sees that. So now that we have this URL here, we can copy this guy, paste it in here. Give me a second. Oh, this is, okay, I'm being very silly. Remember how I said that I'm SSH'd into my desktop PC? So that port forward is on my desktop PC and not on MacBook that I'm running the demo on. I'm going to grab the IP of that device from Tailscale, copy it to the clipboard. And now I should get the Linkerd web dashboard, unless I haven't exposed that port or something. Clearly, I should have run the command. This SSH setup was maybe a mistake, but I have everything installed on my dev machine. I don't have everything installed on my local machine. I'm going to make a new terminal window and port forward into that box. Or I could just, the point is that if you have installed Linkerd Viz, you can run Linkerd dashboard. And if your computer is normal, you should get the Linkerd web dashboard. I'm gonna give up on that for now, so that we can move on with the demo. And then afterwards, I can show off some additional stuff. How do I stop sharing just one thing? Oh, I can't. That's cool. I love Zoom. Okay, so we're gonna go back to my terminal here.
This is how you know it's a live demo, everyone.
Oh God. And kill the Linkerd viz command. And so the next thing we're going to do, we have installed Linkerd viz, so we can run the CLI commands at least. Like Linkerd viz stat. Just for example, so we can run Linkerd viz stat, and this is going to give us a bunch of information that's generated from Linkerd's metrics. And it's telling us here are all of the injected pods in, or all of the injected deployments, right? I ran Linkerd viz stat deploy in the cluster across all namespaces, and we can get lots of great like application level protocol metrics like success rates, requests per seconds, latencies from all of these injected deployments. So, okay, so Linkerd viz allows us to do stuff like that. We can get stats out of the cluster. I should have just used the CLI instead of trying to port forward the dashboard without setting up port forwarding for my SSH connections. That was stupid of me. However, you know, we can use Linkerd viz, we can get stats out of our clusters, and this is all very nice to have, and that's provided by that extension as well. So now that we've go ahead.
The dashboard, if I recall, starts out pretty much showing you exactly the stats that you just looked at there. It's got some other nice things in it, but fundamentally it's looking at exactly this data.
It's exactly the same data. The dashboard is just kind of nice because it's a web app that you can like point and click and go around and click on stuff, and it shows you some kind of nice visualizations of like this service is talking to that service. You get like a box of little arrows on it, which is harder to do in the terminal. But again, if most of you are Linkerd users, you've probably already seen the Linkerd dashboard. We also get some Grafana dashboards that are automatically populated based on the metrics that Linkerd collects. And you can also edit those Grafana dashboards and add other queries, other graphs to them, or you can ingest the metrics from the Linkerd Prometheus installation into another Prometheus and use that for your own Grafana or for alerting rules or for anything else that you might want. We're not going to be doing any of that today. We're just going to be using the things that Linkerd viz gives us out of the box. And one of them is the stat deploy command. So the next thing we're going to do after we have installed Linkerd viz is we're actually going to install our demo application. And the demo application that we're going to be installing is called Emoji Voto. It's the demo app that we use a lot for Linkerd demos and workshops. It's sort of a simple web app where you can vote for different emoji, and we have different microservices that are in this demo app. There's an emoji service and a voting service, and they talk to each other in the web backend that actually gives you like the web app itself. And then we have like a little load generator. So what I'm going to do is we can get this from heck, my bad.
So while you're installing Emoji Voto there, I'm going to answer a question from
go for it.
The chat, which was asking about how exactly the Linkerd proxies get installed and such. Yes, they're dynamically injected containers that get stuck in next to your pods.
Yeah.
So there is a Linkerd proxy running next to all of everything that's in the mesh gets a Linkerd proxy running next to it.
And the way that that happens is that we have in the Linkerd control plane, actually, we can see it right here. There's this component called the Linkerd proxy injector.
Yep.
And the Linkerd proxy injector is a Kubernetes controller that implements a mutating webhook and also an admission controller. So when new resources are created, the proxy injector is going to check, does this have the annotations that mean that this is supposed to have Linkerd proxies injected into it? Does it have any annotations that configure those proxies in various ways? And if it does, it's going to take the object that was submitted to be created on the cluster, and it's going to modify that so that it actually has the Linkerd proxy added. So in a minute, we're actually going to show installing Linkerd into an application. Right now, we can see when we run this stat deploy command, we can see that the only things that have Linkerd installed are things that were provided by Linkerd, right? They all live in the Linkerd namespace or the Linkerd viz namespace. We see that the Linkerd destination, identity, and proxy injector controllers are injected because they just come that way out of the box. They have a proxy running with all of them. And similarly, all of this Linkerd viz stuff is injected out of the box. We haven't installed the app yet, but so what I just did is I curled the emojivoto YAML. Again, in the instructions, there's a bash script in step 6 that if you copy and paste, it will do this for you. But we see that it creates a bunch of services and stuff. I'm not going to read through the whole thing, but if we run context apply -f, and then, I did not want to copy and paste that. I wanted to copy and paste the URL. Oh God. So I just ran a bunch of garbage by mistake. Fortunately, that didn't do anything. So we're going to, now I should not have whacked the up arrow key.
So while this is running,
it's not running.
Well,
I'm just deleting stuff.
While you're deleting stuff.
And I can't send keystrokes to the Linux machine because the control and command keys are flipped because I'm on the Mac. This whole SSH thing, this was a mistake. I'm sorry. I wish I was running this on my dev machine and that I had not thought, instead of trying to set up the MacBook to run the demo, I'm just going to use my real computer that's already set up.
All good.
Yeah, this part is not going well, but that's fine. So you had some stuff you were going to say while I'm trying to delete all of the garbage that I just pasted manually.
I was going to say that there are a couple of things here that I think are worth noting. One of them is that Eliza is going to be installing emojivoto on both the East cluster and the West cluster.
Correct.
And in the real world, you might not necessarily have exactly the same things running on your multiple clusters, but if you're going to use the multiple clusters for failover, then you kind of do have to have something, something to be a target for the failover on the other cluster.
Yeah.
The other thing is that a bit of behind the scenes magic here is that while this is happening, you'll remember that at the very beginning, then we went through and set up all of the explicit trust chain. I almost said trust train. I think
we're making it a thing now.
I think we're gonna have to figure out how to work that into the doc.
Choo-choo.
Yeah. But the part of the point there is that as this is going on, Linkerd has already been configured to do that so that these two clusters are sharing the same trust root, and later the magic will just happen when they try to do TLS across clusters.
Yeah, that's correct. So we have now installed the demo application emojivoto onto both of our clusters. Now, what we're going to see is that Linkerd is not injected into emojivoto. So if we do viz stat deploy, we don't see any of these deployments. We just saw, that this kubectl apply command created deployment.apps/emoji, deployment.apps/votebot, and so on. This is all of the services for the emojivoto demo app. None of them show up here, right? So we can run get po-n emoji photo. So we see all of these pods exist, but we also see it says ready 1 out of 1. So all of these pods have a single container in them. They don't have the Linkerd proxy container yet. So what we're going to do now is we're actually going to inject Linkerd into the emoji photo deployments. And the way that we inject Linkerd is we're going to use the CLI command Linkerd inject. Again, if you are already a longtime Linkerd user, you've seen this a bunch, I am sure. But for those of us who are new to Linkerd, I'm going to do it live anyway. So we're now going to actually add Linkerd to emoji photo in both clusters. And the way that we can do that is using this Linkerd inject command. And the Linkerd inject command, just like all of the other Linkerd CLI tools, it's just going to be like editing the YAML that we're going to get back from a kubectl get. And then we're going to pipe that into a kubectl apply, right? So if we want to inject Linkerd, we're going to run deploy -n emoji. So give me all of the deployments in the emoji photo namespace and output them as YAML. Okay, I get a bunch of YAML back. Here are all of the deployments. Then we're going to do that again, and we're going to pipe it into Linkerd inject --context. West is the default. So if we run this Linkerd inject, and it needs a dash, we run Linkerd inject, it actually prints just a bunch of YAML, right? And this YAML has been edited to add the Linkerd proxy to it. Again, I'm not going to like manually diff them, but the point that I'm trying to make here is that when we run these commands, all that the Linkerd CLI is doing is it's just editing YAML. It's not doing any like manipulation of the cluster. I ran that command. I didn't change anything in the Kubernetes cluster. All I did is your standard Unix CLI tool. It takes something in and it takes some kind of text in that can be like piped into it, or it can be a file, and then it spits some kind of text out that you can pipe into something else. So if we actually want to modify the deployments that exist in our Kubernetes cluster, we're going to take that pipeline that I wrote here. So kubectl get deploy -n emoji photo, Linkerd inject, and then we're going to pipe the output from Linkerd inject into kubectl apply --context west -f --. Right, so we're now telling kubectl, you're going to have something piped into you, and you are then going to apply that on the cluster. So all we're doing here with the Linkerd command is just modifying the YAML that kubectl is giving us, and then we're giving it back to a different kubectl command. So we do that.
Just for the record, I don't see the Linkerd inject command in the README for this, so we will get that.
Yeah,
fixed.
I forgot it.
We'll get that fixed once we're done here.
If you run through all of the other steps, the README is missing the Linkerd inject command. My bad. Sorry about that. So this tells us all of these deployments have been injected with Linkerd. That means that in a minute or two, when I run Linkerd viz and I try to get stats for those deployments, we will actually start seeing them. In the meantime, I also need to do this on the other cluster. So I'm just going to take this same command that I ran and add --context east, and then change the context for this to east, and change the context for this to east. Remember, to get those consistent, you don't want to take some resources that exist on one cluster and then change them and then apply them on the other cluster. So, okay, that worked. And now we can run kubectl get po-n emoji photo again. And we see now these all have 2 containers under ready, right? Remember last time they had 1 out of 1, now they have 2 out of 2. That means that each of these pods, these new pods that were recreated by this kubectl apply, these now have a Linkerd proxy running next to the application containers for those various deployments. So if we do stat deploy, we now see, okay, all of this stuff from emoji photo is now showing up in the stats. And we can see all of these metrics like, okay, there's one pod meshed in that deployment. Well, we just figured that out. We can see success rate, requests per second, latency, and we can see the number of TCP connections. Now we'll notice that some of these services don't have 100% success rates. This is normal. This is because this demo app has some bugs in it on purpose. Those are intended to demonstrate like that you can use Linkerd's metrics to do things like debug errors in an application. We're not going to be doing that today. So it's fine for our purposes that this like voting service has a success rate of 92%. That's because one of the emoji doesn't work. If you want to figure that out for yourself, you can also install this app and you can use Linkerd metrics and Linkerd Viz to diagnose what's going on there, but we don't care about that for now. We're not going to be doing failover based on that decreased success rate. We're going to be doing failover based on availability. So now that we have installed and injected emoji Voto, the next thing we're going to do is we're going to install the Linkerd failover extension. Now this extension, this is like the Linkerd Viz extension, right? That it's an extension that we're going to add to our existing Linkerd installation. This one is still in development. It's a little bit less ready for production, or it's ready for production, but it isn't included with the default Linkerd distribution. So we're actually going to have to add a Helm repo to install this extension. So as it says in the README, you should have Helm installed. We are now on step 7. So I'm going to run Helm repo add Linkerd edge. And as you can see, I already have this repo. So the output from this command is going to look different for you if you have not added this Helm repo. It says Linkerd edge already exists. Yours will not say that if you haven't already done this. And then Helm repo up. Make sure that's up to date. It is up to date because I ran that right before the demo. Yours may not say that. Once we've done that, we are actually going to install this Linkerd failover extension using Helm. So we're going to run Helm install Linkerd failover -n Linkerd failover. So put it in the Linkerd failover namespace -- create namespace because we didn't create that namespace already -- kube context east -- devel Linkerd edge. I'm going to run that. And again, if you are in the README file, step 7 has a bash script that will do this for both clusters in a loop. I'm writing out the command manually because I want to show what some of the flags are doing, but you can just paste from the bash script. So we're going to install Linkerd failover in both of these clusters. Then the next thing we're going to do, that's step 7, is we're going to install one more Linkerd extension in step 8. We're going to install the Linkerd multi-cluster extension. And this extension is, again, it's not part of what you get out of the box when you install Linkerd, because you may not need multi-cluster in every Linkerd installation, but it is included with the core Linkerd distribution. So we're going to install it just from the Linkerd CLI. We're going to run Linkerd multi-cluster install. And again, like every other Linkerd command, all that does is it just gives us a bunch of YAML. And we could look at that YAML if we wanted to, but what we're going to be doing today is piping it into kubectl apply -f context. So we have now created a bunch of additional stuff for the Linkerd multi-cluster extension. We're going to run the same command for the West cluster. And this multi-cluster extension, what this is going to do is that this provides all of the things we need to create multi-cluster gateways to link services in one cluster with services in another cluster. So now that we have actually installed Linkerd multi-cluster, and we can do is at deploy again, just to show that this added the Linkerd multi-cluster namespace, which has one service or one deployment in it. It's called Linkerd Gateway. And that's a component of the multi-cluster extension that actually like creates and manages these multi-cluster gateways. Linkerd. So what we can do now, that was step 8. We're now in step 10, which is going to be actually setting up the multi-cluster, or we're in step 9. We're going to actually be setting up a link between these two clusters. So we're going to run linkerd --context east multi-cluster link --cluster name east. And then we're going to pipe that into kubectl --context west apply -f. So what we're going to be doing now, this is how we actually create the link between the two clusters. In this case, we're going to be linking the west cluster with the east cluster. So what we're going to be doing is we're running this linkerd multi-cluster command to generate the configuration that will create that multi-cluster link. And we're running it in the context of the east cluster, which is the one that we're linking to. But we're applying this configuration to the west cluster, because in this west is going to be the primary cluster where we're actually going to be doing the failover, and east is the cluster that will have the replicas that we're failing over to. So when you create these links, this is actually the one case. Remember how I said, like, make sure that every time you run like linkerd command with the context argument and then a kubectl command with the context argument, make sure you don't like mix them up. In this case, we're mixing them up on purpose because we're telling the west cluster, we want you to have these resources that were created based on information about the east cluster. So in this case, we want to create this link in the west cluster based on configurations from the east cluster. So we're going to run that.
Is there some characteristic error that you're going to see if you like, I don't know, if you forget to mix up the cluster names there? Or...
if you link a cluster to itself, nothing interesting is going to happen.
Okay.
I mean, I actually have not personally tried it. I think that maybe one of my colleagues thought to add some validation to. No, it probably cannot, because the Linkerd CLI does not know like where you are applying the YAML that it's outputting. It's just outputting CLI, and you pipe it into kubectl. I don't actually know what's going to happen if we do that. We could try it just to see. My guess is that that link is just not going to do anything meaningful, because those clusters, a cluster is already conceptually, if not in practice, linked to itself.
Likewise, if you were to now try to link west to east, the other direction, you know, like if you you're only running one command here, where a lot of the other things that you've done have been running them deliberately in both clusters. If you also run the link command the other direction, then does that blow up in your face and tell you anything?
No, it's fine. It's fine to do. We don't need to do it here, because we are creating a link. Specifically, we are going to create then all of the failover resources that we're about to set up. We're going to do all of the failover configurations in the west cluster. We're going to simulate a failure in the west cluster, and then we're going to watch it fail over to the backend in the east cluster. You could create the same link in the other direction. Actually, this is like this would be a normal thing that you might want to do, right? You might want to have, let's say these clusters, they are named east and west. These could be availability zones, right? And you might want to have both availability zones set up to fail over to the other one, right? Because obviously you would prefer to be using the replicas of, this is like one very common failover setup in real life. You would obviously prefer to be using the replicas of a service in the same availability zone, because you don't have to go like across the entire internet to talk to the other availability zone, right? If you are running in like GCP or AWS and you're in like their US East zone or whatever, then maybe the VMs that are running those other containers are like on the same rack as you, or they're definitely in the same data center from that cloud provider, so talking to them is very, so this is where it gets into, okay, unfortunately, communication between computers on the internet is actually limited by something called the speed of light, which sucks, right? Because there's like some extra latency because that data is traveling at the speed of light over optical fiber from like US East to US West, or if the availability zones are farther away from like US West to like an AZ in Taiwan or something, and then that is far away, and then you have to travel at the speed of light. So you would prefer not to do that, but if all of the replicas of the service in the same availability zone as you go down, it would be nice if you could then say, well, we're still running this service in all of our other availability zones. Let's just keep using them until those replicas come back so that, we can still have the application be up for users in US East 1, for example.
So in this case, we're just doing one direction, but
we're doing it one direction.
Very well want to link both of them. Cool.
You may not want to, right? Because you might have like a primary cluster and a backup cluster.
Yeah.
The backup might be like a cold, or like a cold standby that's not normally being used. You might not want that backup cluster to then fail over to the primary cluster. But if you have two clusters that are both like primary production clusters, you might want to be doing failover between both of them so that if either one has a problem, it can use the other. So we could run all of those commands in the same direction. We didn't do that, but we can. So the next thing we're going to do is we're going to actually, now that we've created this link, we're going to export the web service in the East cluster so that it can be used by the West cluster. So the command we're going to run to do that, this is step 10 in the README, is just a kubectl command. Wait, why? What is going on here? My keyboard does not appear to be entering any keystrokes. This is unfortunate. Give me a moment. Is this because my cat is sitting on my keyboard? You are gonna have to leave. You're gonna have to leave. Oh God.
So a minute ago, we were saying things about how this is real life. Yep, this is real life.
This is real, because I removed the cat from, can you all hear me?
We can hear you.
Okay, but you can't see me. I see.
And now we can see you
now
again.
We can see me from the wrong angle. That's cool.
It lets us see your awesome microphone. So
yeah, and my Linkerd shirt. I'm wearing the Linkerd shirt. Yeah. It's not really what I wanted. I wanted to use the webcam, but instead of messing with that, I'm just going to continue with the demo. So in the process of removing the cat from my desk, I unplugged the MacBook from the rest of the world, which included the mic and webcam. And my internet connection went down, so now I'm not connected to. But I can type again, so that's good.
Always a plus.
I now need to connect to my desktop PC again. Did it go to sleep? I'm sorry about this. Okay, I'm back again. I'm having some computer issues. because my desktop PC did in fact go to sleep. And now, is the screen sharing still working?
The screen sharing is still working.
Okay, that's good because, oh God, okay. Now let's see if I can connect to the machine that's actually running the demo stuff. This is great. I may have made some mistakes. My terminal appears to be kind of hung. Gonna make a new one. Y'all are gonna have to give me a sec here. I'm sorry.
It's real life. Go for it.
It is real life, right? So this is how you can tell that this demo is not fake. Is the fact that I can like just absolutely mess it up. You have to give me another minute here. I don't know why this is.
Take your time, and I'm trying to run down answers to a couple of questions from folks while that's going on. So
I will be right back.
Okay. Okay, so there was a question on the Slack about whether or not the automatic injection keeps working if the deployment auto scales or something along those lines. The answer is yes, that should work just fine, as long as you've correctly, annotated it to allow auto injection. Likewise, there was another question about injecting things that are not deployments, and Linkerd inject will work at least for entire namespaces and for stateful sets as well.
Yeah, that's correct.
So hopefully that will answer both of those
Specifically,
questions.
the thing that you inject is a resource that creates pods. So if it doesn't create pods, if it's like a service or something, it does not really make sense to inject that, but it does make sense to inject deployments and stateful sets. And it also makes sense to inject a namespace, and that will then apply the inject to all of the deployments and stateful sets in that namespace. So I am having some network issues of my own, which is kind of ironic. But now I appear to have fixed them. So I will be back online in a minute. It looks like the desktop PC that has all of the demo stuff on it dropped
Off of the Tailscale VPN that was at the time working. I don't know why. I had to just like switch to it, and then so I'm going to be back in a minute.
Of course, you realize that by answering questions in the middle of this, I've arranged it so we can't just edit all this out of the video. So
yes.
Sorry, everybody.
So my embarrassment is going to be seen forever.
Or you could look at it as your ability to debug things on the fly in the middle of a workshop will be seen forever. So
yeah. And my terminal is, oh, I'm not sharing it anymore. One sec. Okay, so we can see the terminal again. I think the font size might be smaller because I had just like bumped it up right before. So I'm going to fix that. Does this look good to everyone, or at least to Flynn? Thank you, Flynn, for.
You could make it a little bit bigger, but I think we're good to go.
Yeah.
Take it back. Take it back. Some of the folks are saying it Saying
big?
some of the folks are saying no. Some of the folks are saying it's definitely would be good to have it be bigger.
Yeah, so when I increase the font size, it scales the terminal window, so it's the same aspect ratio. So I have to like make it smaller again and then zoom scales it. How's it look now?
That looks better to me.
Cool. I can keep making it bigger if we need to. And let's
run with
continue
it.
with the demo.
Yeah, let's run
Okay,
with it.
so did I actually export the service? Did I do step 10? Let's find out.
Yeah, I'm not actually sure, but it looks like you can run it multiple times and it's fine, right?
Yeah, but I would like to find out what is up. So we're going to do okay, we have a gateway. It says alive false because it has no services in it because we haven't exported the service yet. So we're going to do that now. We are going to run this kubectl command --context east. So we're doing this in the east cluster in the emoji photo namespace. We're just going to add a label to the web service. And the label we're adding is mirror.entity.io/exported equals true. We're just going to add that label. And then soon we should actually see that we have this gateway, should have a service in it. It'll take a minute. Oh, I keep running the wrong cluster. Okay, so does have that label set. Mirror.linkerd.io exported equals true. I did that right. Okay, and then the next thing we're going to do is we're actually going to, oh, I need to be in a directory. It has all of the configurations in it that we're going to be applying. And so what we're going to do is we are first going to apply 2 configs that are going to create a second emoji deployment in the there is a problem in the README, and the problem is that we exported the web service, but we're going to be doing a failover for the emoji service. So the README has a bug in it. So we should run the command to add that label, and we should add it to emoji. Okay. And that's a mistake in the README. If you export the web service, but we do the failover for the emoji service, the failover won't work because you won't have exported that service. Don't read the README. So the next thing we're going to do is in the West cluster. West, we are going to apply failover config emoji deploy q.yaml, and that's going to create a second emoji deployment in the West cluster. Because what we're going to do is we're going to do this failover so that we have a primary backend in the West cluster. Then we're going to have a secondary backend in the West cluster. And so it's going to be set up so that if the primary backend goes down, we fail over to the secondary in the West cluster. And then if that goes down, we're going to fail over to the service mirror from the East cluster. And the reason we're going to do that is because it's nice to be able to demonstrate that we can both fail over within the same cluster and to other clusters, and we can do that from the same failover configuration, which I'm going to show you in a minute. And the deployment we want is emoji. We have this emoji deployment, and we're going to we want emoji 2 to show YAML, inject dash. We're going to inject Linkerd into the emoji 2 deployment, and then we're going to actually apply the TrafficSplit for the failover. And because that is sort of the point of this demo, we're actually going to look at that YAML. And fortunately, it is kind of simple. So let's look at failover config emoji fail.yaml. Okay. And so what this is this is the failover configuration for the emoji service. And what this is this is saying this is a traffic split. It is named emoji service. It's in the emoji Vodo namespace, and it has the annotations failover.linkerd.io/primary service is the emoji service. So that's saying this replica, the one that's just named emoji service, is the primary one. And when that goes away, we want to fail over to one of the alternate backends. We have the failover.linkerd.io/controlled by label, which is telling the failover controller, hey, you care about this. And then in this spec, we have this list of backends. We have the primary, and then we have 2 secondaries. And the secondaries are emoji service 2, which is the local replica that is separate from the primary emoji service, and then emoji service east, which is the service mirror. So what we're going to do now, -dash context test apply -f this file emoji failover. Okay, so we've created the traffic split for the failover. Now what we can do, let's look at the gateways. Let's look at Linkerd biz deploy all namespaces. So we have an emoji, we have an emoji 2, we have the other services from emoji Vodo, we have the gateway, and then we have the service mirror in the Linkerd multi-cluster namespace. That's actually, once we created the link from the east cluster, it creates this service mirror east pod or deployment, and that has like the actual component that's responsible for forwarding traffic to the east cluster. And then we have all of the other stuff that we had previously. So then let's look at the traffic split that we just created. Linkerd biz stat traffic split -n emoji Vodo, and that's going to show us that we have this traffic split created, right? And so this traffic split is named emoji service, and the emoji service deployment is the primary, the apex. So we're talking to emoji service. And then we have 3 leaves in that traffic split: emoji service 2, which is the local replica, and emoji service east, which is the service mirror, right? And so we can see that the primary leaf service, emoji service, has a weight of 1. So all of the traffic is going there, has a success rate of 100% because it's working, and then it's getting 2 RPS, right? So 2 requests are going to the, when the Linkerd proxy is injected into the clients of the emoji service, such as the web and voting services, are talking to emoji, they are currently talking to the primary deployment for emoji service. Now we are going to scale to 0 the primary emoji service. That's how we're going to simulate a failure, like if those pods can't get scheduled or something. We can't actually make them fail, but we can tell Kubernetes, hey, we don't actually want this. And then the traffic split controller is going to magically update this traffic split so that we fail over to the next backend. So we're going to run kubectl -- context west kubectl. We're going to scale this to 0 replicates. Now, if we do we see that this emoji service now has no replicas in it. And we should now be able to stat traffic split. And now we see that the weight has changed so that the weight is now 1 for the emoji service 2 service. And we still see that there's a success rate and 1.5 RPS for the backend that we failed over from. That's because these metrics are collected over a sliding window, right? So there were some requests that went there, and over the last however many seconds, I think it's 10 seconds, only some of the requests were sent to the new backend because of the windowing of the metrics. But if we run it again, we will start to see that now the traffic has all shifted over to this emoji service 2. So now we are talking to emoji service 2, which is still in this cluster, right? So we failed over from the primary to a secondary in the same cluster. And if you, unlike me, if you have the Linkerd dashboard open because you are not SSH'd into your Linux box because you're a dumbass like I am, you will be able to see all of this in the Linkerd dashboard as well. There's even a traffic splits page that will show you a table in your web browser of this exact data. And then the next thing we're going to do is, okay, so we failed over from one deployment in this cluster to a different deployment in this cluster. What happens if we then get rid of emoji 2? So now there should be no pods in either emoji service in the West cluster. Let's look at the traffic split again. So, wait, what's going on here? Why does emoji service east not have any traffic going to it? That seems like a problem.
Once again, this is how you know we're doing this live.
Yeah, did I mess something up? Because this worked for me yesterday. Give me a sec.
One thing that I was going to ask about, which might be
Yeah, I'm happy
here.
to answer some questions while I try to figure out what I messed up.
Well, one thing I was going to ask about was earlier when you ran the command to look at the gateways, it still seemed to be saying alive false.
Yeah, let's
I
look
was
at
going
that
to ask
again.
about that.
It still says that. Pretty sure it's that the
Not gonna lie, I
gateway.
love the check commands.
Yeah, so it says there are no endpoints in the service in the east cluster. So let's try running the check command in the east. Oh, that's my problem.
It's not in the mesh.
None of this stuff in the East cluster is meshed. This is an easy problem. That's lucky. I forgot to inject any of those deployments. Context East, get deploy, -n, emoji photo, -o YAML. Normally, when I'm like testing Linkerd, I have a bin directory with like different Linkerd versions in it. So I always type bin Linkerd, even though it's I've actually for the demo installed the like release version of the CLI. Jack -f or dash. There we go. So now we should see why don't we have
your Linkerd inject? You did -- context east dash. Is the second dash?
dash means like except from the pipeline.
Yeah. Okay.
Oh, that was West. No, we do have Linkerd injected into these pods. Let's see.
Does it comment on the chat saying that we're looking at the number of replicas rather than the number of containers? Because we're
so that's fine. That's
which
fine.
Is true.
So that's fine, and I think I should do get pods to see if there are actually proxies there. Yeah. Okay. So we do have Linkerd proxies in those pods.
Good.
Emoji service. Does it have the emoji service? Oh, this is, I did run emoji photo. Oh, that was West. Okay.
Emoji 65.
I can't type. Oh. Okay, that does have the mirror label. Seems odd. A minute here. Worked yesterday in many such cases, I guess. Let's see. So now I guess the demo we're doing here is me debugging in prod, that's fine, I guess. Dash on. See what that proxy is doing. That seems fine. That exists. So we have credentials.
We do have a report from the workshop channel that one of the users there does indeed have this working in their world. So that's a good sign.
Well, so if you were following the instructions from the README and it worked for you, that seems good. I probably just missed a step, maybe while I was in the process of messing up my streaming setup. It's probably what happened.
Is there a way to check that you actually, because you were on like step 9 and step 10, right? Is there a way to
Yeah,
make
I'm gonna
sure
go
that
back and look at the README and see if I had it open because I was like walking through it. Let's see where I'm at.
so step 8 was make sure we have the multi-cluster extension in each cluster.
We definitely did that.
Okay, step 9 was the link.
Yeah, and I'm pretty sure we did that as well because
Is there a way to verify it?
I mean, we ran the check command
Okay.
in the east cluster, link exists, and then we ran it in web cluster, and then, or west, I can't type. And then we see that the gateway mirror is not healthy. And I'm not sure why, because it definitely has endpoints in the east cluster. But one nice thing about Linkerd check is that we did actually add some troubleshooting instructions. So it's possible. Oh, you know, I have a theory, which is that I think that this is my fault because I had hubris. And I think that the reason that it's my fault is because yesterday when I ran through the demo and everything worked, I did it on Civo in like 2 clusters I provisioned on Civo, and they both had external IPs because I think what happened is that I ran today, I thought, oh, you know, I don't need to recreate the Civo clusters. I can just run K3D. And I think that when I provisioned the K3D clusters on my machine, I forgot to make sure that they had external IPs because K3D is running in Docker. I forgot to put them on the same Docker overlay network so that the external IPs would be reachable. Okay. So the problem is we saw the failover. If you are doing this with real clusters from a real cloud provider, everything would have worked. As we see confirmation of from folks in chat, if you are an idiot and a fool like me and you want to be your own cloud provider, you should make sure that the clusters that you created in K3D actually have reachable external IPs. And they don't because they're on separate Docker overlay networks. So they actually, so everything is set up properly, but when we run this, what we're seeing is this can't talk to each other. And the reason they can't talk to each other is because they can't reach any external IPs because they're on Docker overlay networks, and those aren't real IP addresses on the real internet. They're only on my desktop PC, and they don't see each other. So if you were using a real cloud provider like I did yesterday when everything worked, or if you had not misconfigured your K3D, it would have worked. We did see the failover work in my West cluster. And we actually did see the failover work. We saw what would have happened, right? It did update the TrafficSplit. It's just that there's nothing in it, so it doesn't work.
And there's a
I am sorry about that, but if you followed all of the instructions, you would have gotten it to work.
So there's a link posted in the Slack workshops channel to the Linkerd K3D multi-cluster demo, which hopefully has some specifics on how to set that up so that the clusters can talk to each other. Not gonna lie.
Oh, I see that there's a bunch of back scroll.
Yeah, not gonna lie, Eliza, I think idiot and fool is a bit strong.
Well,
because yeah, you know, we did get to see the failover part doing its job,
so
which is nice.
Don't do what I did. That's the biggest lesson that we have learned here. But it would have worked if I had done it correctly. And it seems like everyone else who followed along did do it correctly. So it was easy for everyone except for me, which I think is a teachable moment of some kind, but I'm not really sure what we have to teach. I would want to get it working so that everyone can see, but I don't really want to go through like provisioning new clusters, especially because we are like rapidly running out of time and I want to be able to answer some questions from folks.
Yeah.
Don't try to be your own cloud provider unless you have actually tested it before the workshop. That's like a free piece of Linkerd advice. It's not Linkerd specific, but don't do as I say, not as I do. I'm pretty sure in the email that I sent out, it even says you should use a cloud provider. Don't try to do it in K3D. I'm pretty sure I wrote that in the email. So let's answer some questions.
So I think the immediate
Thanks, Brian.
Well, yeah, I think the main takeaway on that one is, yeah, so we probably ought to go through and maybe update this with some info on K3D as well.
Yeah, and on like how to have.
Yeah, it seems like that would likely be helpful for some folks. Wow, I can't talk today either.
I mean, I think the real lesson here, right, is that multi-cluster works, but the way that it works is by tunneling over the internet, right? Yeah. And the clusters have to actually be on the internet. This sounds very obvious, but you know, they have to be part of the like global IPv4, IPv6 address space. They have to actually have addressable IP addresses. Mine don't, because I don't have an AS number, and I can't actually put things on the real internet. But I also didn't put them. Yeah, I also didn't put them on the same Docker overlay network, because if you want to do that, there's like an extra flag for K3D that you pass, which I neglected to do. So
there is a question on Slack about how this interacts with ingress traffic, and specifically about GKE and GCP native.
So the multi-cluster gateway is essentially, it's not going to go through an ingress that is configured by it's not going to go through any Kubernetes ingress controller. I'm not particularly familiar with the GKE ingress, but it's not going to go through, if that's a Kubernetes ingress resource, it's not going to go through that. You're going to have an external IP address, and you're going to be, that's specifically created for the multi-cluster gateway. And it's going to be talking directly to that. Yeah, I can stop screen sharing this, and I'm going to go back to, can traffic from ingress be shaped by a traffic split? I see, yes, traffic from anything can be shaped by a traffic split.
But if you want to use Linkerd's controller for traffic split, then you need to make sure the anything is meshed.
Right. If the ingress is meshed, then Linkerd can shape that traffic with the traffic split. If the ingress itself honors the traffic split resource, then it might do its own traffic shaping. I don't think the GKE one does, but if you can inject that ingress controller, you can put it in, and and its client is in a traffic, or it's a client of something that is in a traffic split, right? Then the proxy that the Linkerd will honor that traffic split. So if you have a GKE ingress that is sending traffic directly to some service in your cluster that's part of a failover, and that failover happens, the ingress will now be sending traffic to the service mirror gateway, which will then be sending traffic to the remote cluster. So yeah, it works as long as the ingress controller is injected. Ingress controllers, from the Linkerd perspective, an ingress controller is just like any other pod that you might put a Linkerd proxy in. You can inject Linkerd into it. If it's a client of other things, then that traffic will go to Linkerd. Depending on the specific ingress and its behavior, there might be additional things you might need to do to make it work with Linkerd. Specifically, like sometimes an ingress controller will do things like rewrite host headers, and it depends on the ingress. And there are guides on using Linkerd with particular ingresses. But from the perspective of like the routing behavior, it is just any pod that could be a client that has a Linkerd proxy in it is going to behave identically.
Cool. Any other questions? Now is a great time to chime in on the Slack channel or the Zoom chat. Okay, so thanks for sticking with it, everybody. Yeah, kudos for composure to Eliza.
Thanks.
Oh,
I had fun.
Somebody's typing in Slack. We might have another question.
Okay, Conrad Taylor, do we have a question?
Not like we're going to put people on the spot for typing on Slack. Yes, the README.
Yes, I will fix up the README.
Yeah, I actually have a PR for the README that.
Oh, great.
That you're tagged for review.
Awesome. We should also, as Matej mentioned, Oliver had a bunch of stuff for setting up Linkerd multi-cluster with K3D that I have used previously, and I remembered that it worked, and I forgot to use that repo when I set it up this time, because all I remembered was that it worked in K3D, which to me means it works in K3D and you don't have to do anything to make it work. Anyway, we'll fix the README. Thank you for how resilient is the Linkerd control plane? A question from Brian. The Linkerd control plane is, there's an HA setting for Linkerd that you can set when you install Linkerd, and it will configure the control plane in an HA mode where it will create multiple replicas of all of the controllers. The other thing is that the proxies can keep operating without a control plane. If the control plane is there when the proxies are created, and they do service discovery and they get some service discovery information from the control plane, they will continue to use that even if there's temporary and availability issues with the control plane. This does mean over time, right, that service discovery from the control plane may become stale, right? So if you are creating a bunch of, like, if there's a control plane outage and during that outage you decide I'm going to like create a bunch of new deployments or like totally change something, then those proxies may not notice that. They may not be able to talk to the new replicas that are created if the control plane is down. But
well, presumably they self-heal when the control plane comes back.
They will, as soon as the control plane comes back up, they will be updated with like new routing information. But that's kind of a don't do that one, right? Like if you are in the middle of an outage, maybe don't just like also do a bunch of like normal deployments.
Yeah.
Similarly, any new proxies that are created while there's a control plane outage, if the identity service, which is like the Linkerd CA, right, that is responsible for signing the keys for those proxies so that they can participate in MTLS. If the identity service is down when a new proxy comes online, obviously it won't get a key. And if you've configured your mesh to require TLS, which you should, then it won't be able to talk to anyone because it's not part of that MTLS. Okay, and we're maybe done. Okay, oh, right. So before we wrap up, we should just mention that there's going to be another one of these on the 18th of next month. It's going to be about service mesh observability with Linkerd. I forgot who's presenting it.
I think I might actually be on the hook for that one. So we'll find out.
Probably will not try to be his own cloud provider and mess up the demo. So you should definitely come back for that one.
I think it's quite a bit of a stretch to assume that I'm not going to mess up the demo. Yeah.
I mean, everyone messes up demos. It's normal.
The other thing that we were going to point out is there is this thing called Buoyant Cloud that if you're interested in having something other than the humans managing your Linkerd installation, you might be interested in taking a look at that.
Yeah, it can do things like automatically update Linkerd to the latest version and give you some monitoring and maintenance tools for your Linkerd deployment. Yep. It might do exciting things related to multi-cluster in the future as well, but that's the teaser.
Oh, and I'm sorry, there's one other question that we had on Slack about making Linkerd 2 use console and such.
Yeah.
think so.
So no, not really. If you wanted it and you wanted to write some code to make it happen, you could, right? The Linkerd proxies have an API that they use to talk to the Linkerd control plane for service discovery. That API is just a gRPC API that the Linkerd control plane implements. If a person was really dedicated and they wanted to get that service discovery from console, you could probably write a controller that reads from console and serves that API, and you could point proxies at it and they would work. This is not a supported way of deploying Linkerd. If somebody wrote that, and I would be impressed and I would be like, wow, that's really cool. But no, not out of the box. No, it doesn't natively support console.
There are a lot of fascinating things that you run into when you start trying to do service discovery from multiple sources at the same time.
You will have a bad time.
Yeah,
but you could do it.
This is the last one we're going to take. Can Linkerd peacefully coexist with Envoy or other service meshes? I think it depends on what you mean by peacefully.
Yes, my answer to that question is it depends.
Yeah.
And it depends on what you mean, and it's kind of a complicated question. Yeah. So sorry, that's a non-answer, but it's
it might be worth
it is a long story that I think I would be happy to have like a conversation about that on Linkerd Slack or something.
Yeah,
because
like arranging for things like ingresses to coexist with multiple service meshes ends up making a fair amount of sense, and arranging for multiple service meshes to interact with each other can be a little complex. If your API gateway is using Envoy, okay, so for example, emissary ingress uses Envoy and works just fine with Linkerd.
Yeah, okay, so this is really, I guess this might be the answer to the question. Linkerd will happily coexist with Envoy, right? It may not coexist if you, there is a difference between an Envoy proxy, which is just a program that like makes requests to the network and like receives requests from the network, and a service mesh where like, if you are doing IP tables things so that all of the traffic going to and from a pod is going to an Envoy, and you also want to put Linkerd there, you can't have those redirects work so that the traffic goes to both the Linkerd proxy and the Envoy proxy. If you're using Istio, right, a service mesh that actually manages Envoy, installs it into pods, and configures routing between, like, configures IP tables, redirects in those pods so the traffic goes to the Envoys, you can't also have Linkerd be there. But if you're using an ingress controller that uses Envoy, or if you just have like a custom Envoy setup that is like doing some kind of routing, if you inject Linkerd into that Envoy, you're fine. It'll just work. Envoy is just another process, right? There's a difference between coexisting with proxies, I guess, and coexisting with service meshes. A service mesh kind of wants to own the world, right? And it doesn't really work unless it can do that.
Unless it does own the world.
Yeah.
Okay, thanks very much.
Thanks everyone for coming and for putting up with some of the technical issues that we had. Whew.
Thanks much. We'll see y'all on the 18th, I guess it was.
Yep.
Yeah.